This is our video for lesson 3.6. So in this lesson, we're going to talk about graphing linear equations in slope-intercept form. So we're graphing straight lines, and we're specifically going to look at them being written in slope-intercept form. So we'll say more about that form in just a minute. First thing we need to think about, though, is slope. So slope is kind of like the angle of the line. If we draw a straight line, we can draw it a lot of different ways. And so slope is the number that represents the angle of the line. Positive slopes go up as they go to the right. Negative slopes go down as they go to the right. If a line has zero slope, that's going to be horizontal. And undefined slope is a vertical line. So lots of different ways we can calculate or find that number that represents slope. And we use the letter M, this kind of cursive letter M, to represent slope as well. If we're calculating it based on coordinates, we're going to use this method right here. And we also represent slope as the change in y over the change in x, which we can think of as rise over run. So a lot of different ways that we talk about the very same thing. So let's just jump in and start looking at some of these examples. So if we're looking at example A, again, we can think of this in a couple of these different ways that we've talked about slope. So slope is always going from one point to another point. We're figuring out how far over and how far up we go. So if we're thinking about it from that perspective, this left to right is what we call the run, and then the up and down is what we call the rise. So if we're thinking about slope as rise over run, this would be 4 over 6. We do always want to simplify our slope whenever we can. So 4 over 6, both of these numbers can be divided by 2, and that would simplify down to 2 over 3. So notice that is, we used 2 over 3, so we simplified this to 2 over 3, so it was 4 over 6, so up 4 over 6. We can use any simplified version of this slope as well. So if I go up 2 and over 3, this will be another point on the graph. So any multiple or simplification of this slope will work. We also talked about slope being change in y over change in x. And that's basically the same thing. This is the change in y from one point to another, which was 4. This is the change in x. So again, that would be 4 over 6 or 2 over 3. And then finally, if we want to calculate it, so we've got y2 minus y1 over x2 minus x1. And again, this is just another way. This is a way that we can calculate that change in y and the change in x. And we're going to do that. I'm just going to get that out of my way because it's just getting a little bit messy. If we're going to do that, we need to just label our points. This is x1, y1. And this will be x2 comma y2. The reason we do this is I've got 2 different points. So like this is point number 1. It has an x and a y. This is point number 2. It has an x and it has a y. So this is just a way for us to differentiate those different coordinates. So now I'm just going to substitute in. So on the top, I've got y2 minus y1. y2 is 2. y1 is negative 2. So I'm just plugging those values in. So I've got 2 minus negative 2. And I've got 3 minus negative 3. And if we simplify that, that comes out to, I'm running out of room here, 4 over 6, which is the same as 2 over 3. Okay, so again, we should always end up at the same spot no matter which method we use. So instead of going through all of those methods again, I'm just going to go through the coordinate method. You may actually, if this is your first time through this, you might want to just pause and try this on your own and then come back to check your work. y2 minus y1 over x2 minus x1. So let's label our points. I'll call this x1, y1, and I'll call this x2, y2. And it's important to note, I could have flipped these, meaning I've got this as x1. I could have made this x1 instead, and it would be fine. It won't matter. You'll get the same answer. The only thing that's important is the 1s and the 2s have to stay together. In other words, if this x value is x1, this y value has to be y1. Okay. All right, so let's plug in and simplify. Negative 1 minus 2 over 2 minus 0 is negative 3 over 2. And no matter which method you use, you should always get negative 3 over 2 as the slope of that line. Okay, moving on to tables. So again, a couple different ways we can think about this. I'm first going to think about change in y over change in x. So these are just points that are on the line. Okay, they may not be in order, it's just a list of points that are on the line. And if we want to think about change in y over change in x, we're just going to look at any pair of points. So I'm going to think from 4 to 7, what is the change in x? Not plus 1, plus 3. And from 20 to 14, the change in y is minus 6. So change in y over change in x, negative 6 over 3, which if we simplify, negative 2 over 1. Technically, 6 divided by 3 is just 2. I always write slope as a fraction, though, because that helps me remember that it's two parts, right? It's the rise part and the run part. Change in y over change in x. We could also do that same method we were doing before, just using these points. So I would call this x1, y1, x2, y2. So I could do 14 minus 20 over 7 minus 4. And again, same thing. And we could simplify. B and C are going to be kind of unique results. Again, you may want to just try this on your own and then come back. So again, change in x, this is plus 2. Change in y is 0. There's no change. Okay, so if we're thinking change in y over change in x, that's going to give us 0 over 2. And actually, before I simplify and say more about this, I'm just going to do this other one here as well. The change here in x is 0. The change here in y is 3. So this would have a slope of change in y over change in x, 3 over 0. Okay. So notice what I've got, 0 over 2 and 3 over 0. One of these slopes is 0 and the other slope is undefined. 0 on the top is okay. I can take 0 and I can divide it by a number and I get 0. However, if 0 is in the bottom of our fraction, this is not okay. This is never okay in math. That gives us something that we say is undefined. So here we have a slope of 0, and over here we have a slope that is undefined. All right, now we're going to start thinking about this whole slope-intercept form. So when we talk about a form, we're talking about the way that the equation is written. So we've seen slope-intercept form. Okay, slope-intercept form is y equals mx plus b, where m and b are just numbers. Right? So for example, like this is a perfect example of slope-intercept form. I've got y, m is just a number 3, x, and then I've got another number here. Okay? Perfect example. In slope-intercept form, the reason it's called slope-intercept form and the reason it's a nice form is because it's easy to plot a graph from this form. In this form, whatever that value of m is, this is your slope. So if it's in this form, you don't have to do any calculation. You just have to say, what is that value of m? In this b, this is your y-intercept. Right? That's where the line crosses the y-axis. So those are really nice to have. Another form you might remember is standard form. And we were using this recently, and that looked like this, ax plus by equals c. So notice it's got basically the same components, they're just kind of rearranged. And we can always take a standard form linear equation and turn it into slope-intercept form and vice versa. So we are going to now find slope and y-intercept. And if these equations are not in slope-intercept form, we will want to get them into slope-intercept form. So, like I already mentioned, this one is already there. Y equals 3x minus 4. This is my m, this is my b. So my slope is 3. And my y-intercept is negative 4. It's important to notice that I'm taking that sign with it, right? If that's a minus 4, my y-intercept is negative 4. If it's a positive 4, then my y-intercept would be positive 4. In part B, this is still a linear equation. It is in slope-intercept form, but what's missing? Hopefully you notice that it's missing an x. And all that means is that the slope is 0. Right? We could write this as 0x plus 6.5, meaning our slope is 0 and our y-intercept is 6.5. Notice I'm using these letters interchangeably for slope because they mean the same thing, and that b value here is the same as y-intercept. Finally, here, we need to rearrange a little bit, okay, because our goal is to get it y equals mx plus b. So we have to basically solve this equation for y, and it has to be a positive value of y. Right now it's negative, so that tells us we've got to do at least a couple things, because I've got to get rid of this negative 5x, and I've got to make that y positive. I'm actually going to make that y positive in a little bit different way. Because if I add y to both sides of this equation, negative 5x equals negative 2 plus y. Now I've got my positive y. I just need to get rid of this negative 2. And I can do that by adding 2 to both sides. So, negative 5x plus 2 equals y. And whenever we have an equation, I can always flip what's on each side of the equation without changing anything. So y equals negative 5x plus 2. And again, now it's in slope-intercept form, so it's really easy to pick out my slope is negative 5. My y-intercept is positive 2. Be careful here with your slope. A lot of students tend to say that the slope is negative 5x, and that's just not true. The x is not part of the slope. It's just the y. I'm sorry, not just the y. It's the number attached to that x. And again, I always like to write it as a fraction, so we remember that this is the rise and this is the run. And then our y-intercept is positive 2. All right, moving on to graphing. So we have to get this first into our proper form. So that's quick and easy because I've got a positive y already. If I minus 2x from both sides, we end up with y equals negative 2x plus 4. So again, my slope is negative 2, and my y-intercept is 4. So here's how we graph this. Once I have those two values, y-intercept, remember, is where it crosses the y-axis. Ooh, kind of close there. So it crosses the y-axis at 4. So I know that one point on my graph is right here. Now from there, what I'm going to do is I'm going to use slope to find additional points. So remember, this is rise over run. So in other words, this is how much does it go up or down and how much it goes right or left. So since that's negative 2 over 1, it's going to go down 2 and right 1. Okay, so that's a point on our graph. Down 2 and right 1. And from there, we can just draw our line. Try to make this as nice as possible, not bad. It does also ask us to find the x-intercept, and remember that's just where it crosses the x-axis. So in this case, it's nice and easy. It's a nice clean intersection there. The x-intercept would be 2. Is 2, or we should really probably say 2 comma 0 because that's the coordinate. If it wasn't nice, you may be asked to estimate it, meaning kind of guess what it is, or we could always do what we did in the last section, and we could let our y equals 0 and then solve for x. That'll do the same thing. That's all we got.